Hello, everyone, and we're going to start solving this worksheet that I gave you last class. Now, the first question says that it's about a cup of water at 0 degrees and a mixture of ice and water. Now, the question says state and explain which cup contains the liquid with the lower temperature after 10 minutes. Now, the statement would be the mixture, all right, of ice and water. The explanation, it will remain at 0 degrees. Nothing, it's not going to increase because there is ice. And it only increases when all the ice melts down. So it will remain at 0 degrees until all the ice melts. Alright? Ice will absorb the energy. Alright, so you get 2 marks for that. Now, the second one is on hot days, sweat forms on a person's skin and then evaporates. Explain in terms of molecules how the evaporation of sweat cools the person. Now you got to speak about evaporation a little bit. And we're going to say evaporation is the escape of the most energetic molecules. Okay? This reduces the average kinetic energy, cooling down the liquid. Alright, to get a mark extra from here, you say the energy, the liquid takes energy from the person cooling him down. Alright, then you get the 3 marks here. Explain why this process is more effective when a wind is blowing. Don't beat around the bush. Just directly say wind increases the rate of evaporation. Alright, and this ends up the first page. Okay? Going on, looking at what's next. Now, I want you to be very careful with the command terms like describe. Describe this movement. So they said that pollen particles in a liquid are observed in a microscope and describe their movement. Don't say Brownian motion. They didn't say name the movement. They say describe it. You're going to say random, zigzag, motion. This is how you describe the movement. Explain this movement in terms of the molecules of the liquid and the pollen grains. You say the heavier pollen grains are being bombarded by the fast moving water molecules. Alright? And this is the answer for this question. Alright? Now, the next question, I hope that you can see the question well. You have the paper. So it says medical professionals sometimes rub ethanol over the skin of a patient. Ethanol evaporates readily at room temperature. State whether the patient experiences heating, cooling, or neither. The patient is going to experience cooling because evaporation has a cooling effect. Explanation, the most energetic molecules, okay, uh, I'll say absorb heat energy from the skin as they escape. That's a very decent answer. All right. Now to escape, and you can say uh, to overcome the forces of attraction do not exceed the spaces given. Sorry, people, my handwriting is just. I'll make it better. I'll make it better. State any effect on the rate of evaporation of ethanol when a fan blows air over the patient's skin. Uh, it will increase. That's it. You don't need to say anything else. The rate of evaporation will increase. Okay. Now, the question about the cup and the holder, it says that explain how using the holder makes it more comfortable to hold the cup. Okay? Explain. Now you gotta say the holder reduces heat transfer by conduction. Okay? As the paper and air gap are bad conductors of heat. All right? All right. A student carries out experiments on the cooling of the hot drink described in A. With and without the holder in place, he finds that the holder only reduces the rate of cooling slightly. Suggest and explain another action that reduces the rate of cooling more effectively. I'm going to say adding a lid. When you add the lid, you reduce heat loss by convection or evaporation. Okay? So, reduces heat loss by convection and evaporation. You gotta mention the both of them, yeah? Because now you know that a lid reduces heat loss by convection and evaporation. Okay? Now, state the method of thermal energy transfer from a star through vacuum. Okay, this is like radiation. You can say radiation, you can say infrared radiation, whatever. Okay? Now, let's try the next one. State why the pan is made from aluminum while the handle is made from plastic. All right? So, it's a simple answer. Aluminum is a good conductor of heat, while plastic is an insulator. Okay? Now, the hot plate switched on, and as the temperature of the water increases, the internal energy of the water increases. State in terms of molecules, what is meant by increase in internal energy? Now, the particles gain more kinetic and potential energy. Okay, so the particles gain more kinetic and potential energy because internal energy is the sum of kinetic and potential energy. Don't say just kinetic, all right? Now explain in terms of the atomic lattice and electrons how thermal energy is transferred through aluminum. This is thermal conduction, people. So the atoms or ions vibrate and collide with the neighboring atoms, passing on the heat. Electrons collide with atoms, passing on the heat. So two things, free moving electrons and lattice vibration. Okay? Now, moving on. In terms of momentum of molecules, explain how a gas exerts pressure on the walls of the container. Now, so what we're going to do is, we're going to say, uh, as the molecules strike, the walls, they experience change in momentum. This is caused by a force. The sum of all the forces due to collisions, okay, divided by the total area gives the pressure of the gas. This is how you answer such a question, people. I swear my handwriting is nice, but it's the pen. It's the pen, people. Okay? All right. Now, moving on. So if you have something like it's the relationship between volume and pressure. So we know that P1 V1 equals to P2 V2. That's something we know. P1 V1 equals to P2 V2. If you want to make P2 the subject, it's P1 V1 over V2. Okay? Now state and explain how the final pressure compares with P2 when the temperature of the gas increases during compression. Now when temperature increases, just make it simple. Pressure will increase. Okay? Molecules collide with walls more frequently. And this increases the force, increasing the pressure. All right? What else do we have? All right? Or you can say that the molecules, okay, we add gain in kinetic energy. That's something you can add, you can leave it behind, that's totally fine. But you know that when temperature increases, the molecules gain kinetic energy. And you gotta mention it, when they gain kinetic energy, they collide with the walls more frequently. And this increases the pressure. Okay, people, we're almost, I'm not gonna say we're almost there, but we're doing well, we're doing well. Now in this question, it says that a large test tube contains a liquid at room temperature. An electric heater is immersed in the liquid and switched on. Thermal energy is supplied. The temperature of the liquid increases until it reaches its boiling point. The liquid then starts to change into a gas. Describe in terms of molecules and their motion how a liquid differs from a gas. Okay. The molecules in a liquid are closer together than molecules in a gas. Now, this is difference number one. The molecules in a liquid slide past each other, okay? While in a gas, they move freely in all directions. These are like two differences between molecules in a liquid and molecules in a gas. Okay? That's it. That's it. Describe what happens to molecules of the liquid as the temperature begins to increase. They move faster. You say more kinetic energy. Don't say KE, say kinetic energy. Okay? They occupy more space. They expand. You gotta be very clear when doing that. Explain in terms of molecules why a supply of thermal energy is needed to change the liquid into a gas. Come in. Muhammad Yasir, I'm solving the worksheet. Come close. You want to say hi to me? People, just I'll be right back.